For microbes to cause disease, they have to first be able to get into our body. And so they're going to do that in many different ways. Some produce toxins that then can be ingested, while others are going to get into our body and colonize and then start producing toxins. Some, when they do get into our body, they're going to avoid our host defenses and start out competing the normal microbes that are there. But in any case, you have to first be able to get into the body. And so to do that, they have to have special adherence factors. So either adhesions or fimbriae that allow them to attach to host tissues. And once they can attach to the host tissues, they then can potentially cause disease. They're going to, so once they're attached, they're going to have to start replicating. And if they start replicating and they form a biofilm, they're going to be more protected than if they don't form a biofilm. So some will form a biofilm. There are some microbes that have the ability to stay away or avoid immunoglobulins, antibodies. Antigenic variation, which I've talked about before, is one way that they can avoid the antibodies. There are proteases that will break down some of these antibodies, so that's another way that they're going to do so. So once they are have colonized, they now are going to have to get inside the cell. So they've colonized the tissue. Now they have to be taken in to the body. There are different ways that this can happen. Some gram-negative bacteria use a type 3 secretion system where the cells actually are converted, they're changed, and it causes the cells to take in the bacteria. Typically, so there are a lot of mechanisms or a lot of ways that microbes can get into the body. Most common ways are through the oral route, oral fecal route, or through the respiratory route. Microbes are breathed in. Microbes are taken in when we eat or drink materials. That being said, some microbes will get in through our skin. So if you have a cut in your skin, then some of your normal microbes like staph can get right through this. Other microbes can penetrate through the skin via injections. Yersinia pestis is an example of that. When fleas try to bite you, they actually will stick their proboscis into your body and they will inject the Yersinia pestis directly in, more or less accidentally, because they stick their proboscis in, they start sucking your blood, and because their gullet is completely clogged, they can't get the blood down, and so they end up vomiting back into you. And when they vomit your own blood back in, some Yersinia pestis go in as well. And then some cells have the ability to use certain uptake systems, like that type 3 secretion system, to cause our own cells to take them in via endocytosis. Once they get in, now they have to protect themselves. So some of these microbes are going to hide within our host cells, and so typically our host cells are going to immediately, when they recognize that there's this new organism inside, they're going to break that organism down using our lysosomes and the digestive enzymes. But these guys hide from those different enzymes and just sit inside the cells. And so so we don't produce those major histocompatibility complexes that will show self and non-self together. Um, some microbes will actually bind complement proteins, and so a complement system is another mechanism that we use to protect ourselves. And these guys will bind those complement proteins so that the complement system never gets activated. I'm so sorry. Ugh, I have a lot of yawns this morning. So I will say it's bright and early in the morning. That could be why I'm yawning because I'm not drinking enough coffee, you know? Um, so once they're inside, now they're going to cause either direct damage to the cells or to the body or indirect damage. Direct damage is caused by the toxins that are produced by the bacterial cells, while indirect damage is caused by our immune system responding to the cells. The damage that is caused is typically what will help to spread the pathogen from one organism to another. So let's look at some types of toxins that are released from different cells. I've talked about endotoxins, which are released only by gram-negative bacteria. There are also exotoxins that can be released by both gram-positive and gram-negative. Exotoxins are proteins that are produced by bacterial cells. Um, Exotoxins are not released only upon bacterial death, while endotoxins are. Exotoxins are seriously intense toxins that you need very small amounts to cause problems. There are three basic groups of exotoxins. We have neurotoxins that cause damage to the nervous system, enterotoxins that cause damage to the digestive system, and then cytotoxins that cause damage to multiple cell types. So here you can see both gram-positive and gram-negative bacteria that can produce exotoxins, and there are different types of exotoxins that are produced. Here are some more membrane damaging toxins, superantigens. I'm not going to ask a ton of questions about all the different microbes and what type of exotoxins they produce. What I do want you to know, though, is that some are neurotoxins, some are enterotoxins, and some are cytotoxins. And so, like, just know that you have these organisms here that produce neurotoxins. Here you have some enterotoxins, and then here you have some cytotoxins, okay? And then we have endotoxins. Endotoxins are the ones we've already talked about. They're a part of the bacterial cell membrane. And so when the bacteria die and that cell wall is broken apart, the endotoxin is released. Lipid A is the endotoxin. It's part of that lipopolysaccharide. And when it is released, it causes severe, intense fever because it's what moves to the hypothalamus and sets our body temperature at a higher temp. This can activate both innate and adaptive defense mechanisms to try and clear the disease. Since it's a lipid, it is not heat labile or it's not heat sensitive. It's going to be heat stable. Um, and so people who have gram-negative infections often end up getting sicker before they get better because of this high temperature that the body is going to have. This is a comparison between exo and endotoxins. Sometimes I ask questions and I'll say, what are the differences between the exo and endotoxins? And I ask you to give me two comparisons that are the same and two differences. So just kind of a hint on your next exam. This is from a different textbook, but it's something that I wanted to use because it talks about portals of exit. So once the disease has run its course, the microbes are going to want to leave. And so some microbes, no, not some, most microbes are going to enter and exit through the same route. So if the route is through respiratory, you breathe them in, then you're probably going to sneeze or cough to get rid of those microbes. If the infection came through the oral fecal route, you ate something, the microbes will likely go out through that same route through defecation. So that's what this is talking about. This end of our chapter, so I'm going to go into chapter 19 next, okay? Have a great morning or afternoon, I guess it could be afternoon when you're watching.